The goal of this talk is to let you know what Tom Toolkit is, if you don't know, and go into some of the details of its scope. We've talked about so many things here, and this slide is just to put things in context, the whole network of software services that is driving this science. And so I'm going to be focusing here on Tom Toolkit, and I should first of all say Tom Toolkit TOMs are what Tom Toolkit is designed to create. When I say TOM, I mean Target Observation Manager. And the other word that you've heard for that in this context is Marshall. So I'll be using TOM when other people will use the term Marshall, but I think they are synonyms. I want to mention that, yeah, Sky Portal is another different philosophy toolkit. I don't know if it's a toolkit, but you can also create a Marshall or a Tom using Sky Portal as well. But Tom Toolkit is my thing, and that's what I'll be talking about. And actually, I shouldn't say it's my thing. Rachel Street is the PI of this project, and this is, of course, the work of many people. I'm just one. Okay, so yeah, most of this is about Tom Toolkit, but then I also want to talk about a little bit of the future, where we'll talk about AON-LIB. AON-LIB will be a component of the existing AON network, Astrophysical Events Observatories Network, and I'll talk a little bit more about what that is later. But yeah, I'll focus on that. But first, Tom Toolkit. All right. So this places the Tom in the context of the services that it interacts with. Yeah, this is, and I'm going to show you pictures of what Tom Toolkit looks like next. But our goal here is to write software that is a toolkit that you can use to create a Tom and interact with services that are external to your Tom. So I'll be focusing on interfaces with observatories. Your Tom can submit observation requests to observatories that we have facilities for, interface with brokers and alert streams. You can share data between other Toms, or you can just put your data out on a Kafka server, however you like. I'll also be focusing on how you might integrate your science-driven software that is specific to your science with the Tom Toolkit. Okay, so this is just what the Tom Toolkit looks like. I'm showing you screenshots of what we call Tom Demo. We at LCO, Las Cumbres Observatory is where Tom Toolkit comes from. We deploy a demonstration Tom. We call it Tom Demo, and I'll give you that URL later. But this is a web-driven application. It manages lists of targets, and then you can go to target details. It's a classic thing. You've seen it all over. Lists and details. It's like your email list and the details of that email. This is your target list and target details. Given a target, we have our target detail page has tabs where you can submit observation requests to facilities that we have plugins for. You can manage your observations that have been submitted and come back. You can manage your data. Yeah, so that's all part of the toolkit. Here we're looking at the observations tab. This is Tom Demo. So this is just demonstration data. You can see things like, oh, this target has an extra Boolean that we've called false. It's just to let you go to a place on the web and examine what Tom Toolkit could be. So more specifically, so that's what it looks like. Tom Toolkit is an open source Python package. It's Python because Python is the language that astronomers enjoy. Like you're glad I'm not talking about JavaScript. It's based on Django, which is Python's web application framework. It's well documented, and I'll give you the link to that documentation. The key thing is that we're writing a toolkit. It's not a service, and the toolkit is there for you to write your own services for your science. So we have interfaces to telescope facilities, brokers. I kind of mentioned these in that context picture. Yeah, so I'll move on. Again, we're back at that context picture, and I'm going to start talking about some of these things in detail. I described, so the way Tom Toolkit is structured is that there's a base Django project that has data models for your targets, for your observations, for data products, and things like that. And then we have, this is actually from our GitHub, is a list of GitHub repositories, just a small list. But each one of these things is a plugin that you would install into your Django application, into your Tom tool, into your Tom. And for example, you can, if you install Tom Swift into your Tom, that will give you an interface to submit TOO requests to the Swift observatory. On the other hand, like in terms of getting data in, we have interfaces to the brokers, and I'll talk a little bit more about that. We have some are more science specific. So we have a module that will help you pursue, well, Tom non-localized events used to be called Tom super events, but then we realized that there's other things besides gravitational waves that are not localized in the sky. And so Tom localized events is designed to help you do follow-up on those events. Yeah, so there's a whole range of these things. This is just a subset. Yeah, TNS, if you can get classifications in and out of TNS as well. Okay, so now I'm going to start zooming in on some of these things. Just in terms of the facilities, this is a list, a partial list of the facilities that we support now, and some of these are coming straight out of Tom Toolkit. They need to be configured with credentials and whatnot. Others are plugins that don't come straight out of the box. Our Tom ESO facility is probably of interest here, but the ESO P2 tool is so nice, and Joey and I, my colleague who developed Tom Toolkit, couldn't possibly reproduce that Angular front end. So in a facility like this, our goal is really to make it such that you don't have to fat finger your RA DEX from one place to another. If you have a target in your Tom, we can put that RA DEX into the ESO P2 tool, and but then we're going to hand off the submission of that observation request to the P2 tool. So, I'll talk about how this is going to work in the future when I get to the end of this talk. Okay, interface with the brokers. There was a time when an interface with the brokers was a database query, but that's all changed now. But we still maintain this. You can define a query to, this is even an incomplete list of the services. And yeah, you could define that query, you could run it periodically. This would generally give you a list of targets that may or may not already be in your Tom. You could click on the targets and ingest them into your Tom. But now we don't do that. Now we listen to alert streams. And so, yeah, early on we wrote, I wrote this Tom alert streams module. It allows, this kind of gets back to the idea that you guys should concentrate on your science, and you don't want to worry about what does it take to write Python code to listen to an alert stream. And you don't have to do that. Like, you just install this into your Tom. this would go, this is a everyone's happy to see Python, right? Yeah. We haven't seen a lot of code. But yeah, list of dictionaries. This is a configuration dictionary that's listening to GCN. And the key thing here is we just take a topic from whatever alert stream it is, and we map it to, in this case, these are just loggers that I've written, but you would map the alerts coming from a specific topic in your alert stream to a function that you write that takes the alert, parses it, does whatever your science requires of that alert. And this is about the simplest thing that you could do with an alert stream or the brokers. And we've just heard about all the functionality that the brokers are providing beyond just a stream of alerts. And yeah, that just let us know what your use cases are, and we can try to expose those or just build on top of them, I think is the right thing to do. Okay, so the Rubin data centers and interfaces with that. Right now, we're just kind of getting started. You can query the Rubin Science platform in the most rudimentary way. So the Rubin Science platform is built on the software called Firefly, which is it's a web application. I'm looking into how we can best integrate with that, or how to get data in and out of your TOM via the Rubin Science platform. So that's underway, but yeah, this is just getting, yeah, we're just doing tap queries here. So this is kind of key. So your science is unique to you, thank you. And you've written software to support your science. It's specific to your group. And I just want to give an example of how that works. Basically, this would be done via the TOM toolkit, calling out to your software and doing what it needs to do and interacting back with your TOM. And the case that I want to outline here is, it's not the science that I'm talking, because that's not my story to tell, that's Katarzyna's story, but the workflow here was that this is the microlensing observing platform MOP. It's a TOM that was developed at LCO. And but the workflow was that MOP ingested an Google alert, did modeling and prioritized assignment of the follow-up of that alert, and put it on a cadence, and basically found this planetary anomaly pretty much automatically. The observation was requested automatically, and then they were able to do follow-up there. But this was all done with interface that they wrote and integrated into the TOM. Okay. Great. So there are TOMs out there working, and these are kind of categorized. SNEX2 supports the global supernova exchange, and MOP, I just mentioned, is the one that Rachel Street is using for her microlensing program. There's a couple of TOMs under development that are supporting Rubin Science collaborations. The OPM TOM, this is coming out of Heidelberg, is supporting transients and variable stars. Tim Lister at LCO is working on FOMO, follow-up of moving objects TOM. That's the solar system science collaboration. There's a couple of TOMs that are supporting surveys, Saguaro, and the GEM TOM is supporting the black hole survey. We'll hear about black hole TOM next. And then these, so black hole TOM and GOATS, this is for Gemini, developed at Noir Lab, are examples where the TOM toolkit has been integrated into a much larger system that functions beyond just like a science group's science. Some unique application, if you're asking you did what with TOM toolkit, that's a good sign. And so the Dark Energy Science Collaboration used TOM toolkit to support their elastic challenges. And calibration time is actually what we use at LCO to submit calibrations on standard objects. Okay, so where to find more information? So you can go to Tom Demo, play around. You can actually, I'm already registered, but there'll be a register button. If you're not there, go ahead and register. Don't put anything important in there. We'll go through and delete that database every once in a while. This is our GitHub project board. So Tom Toolkit is developed completely out in the open. If you want to know what we're doing on any given week, this project board will tell us. So each one of these items represents a bit of functionality that we are working on. We go through this list of triage every week. If you have issues with Tom Toolkit or features requests, go to this board, create an issue. We will review it that Friday and probably get back to you and talk about priorities. And this is how we just manage our work week to week, day to day. I will upload these slides, so these links will be available to you. I want to talk about AionLib very quickly. AionLib exists in the context of the Aion network. This is a network of robotic telescopes that are designed to do time domain science. So this is basically the minimum things that you can do to be part of this Aion network or be compatible with it. And that just means taking requests electronically and being queue scheduled part of the time. Aion Plus is the bigger project that is expanding this Aion network to some big telescopes that will hopefully get down into the deeper fields that LSST will see. And we're also looking at radio observations and trying to get those coordinated. What I really want to talk about is AionLib. Am I at 2 or am I done? Okay, the one thing I want to talk about is this. So right now, what if you want to submit observation requests, but you don't want to use Tom Toolkit? Right now, those facility modules are part of Tom Toolkit. And basically what this is, we're going to refactor that out of Tom Toolkit into AionLib. So yeah, so you can use Jupyter notebooks or your own custom Tom, or if you have a Marshall of your own that might be able to use this, you can access telescopes in this, well, you need time, but in the network, but you don't have to use Tom Toolkit to do it. Okay. Yeah, this is a real project. It's under development. It's in early stages, but we have our Jupyter notebook that kind of demonstrates how you might submit the same target to LCO and to ESO. More about AionLib, you can get those from the slides. And a summary slide, so I think I'm done.
Yeah, okay.